Hello students, welcome to MJC Learning. I am Manju Dilip. Today I am going to start with 12th Standard Mathematics Paper 1 First Chapter Mathematical Logic Part 6. So we already studied the topics negation of compound statements, that is negation of conjunction, negation of disjunction, negation of implication, negation of biconditional and negation in the previous slide. So today I'll start with the topics negation of quantified statements and converse, inverse, contrapositive of a statement. So today we'll start with negation of a quantified statement. We already studied quantified statements which are starting with any one of the quantifiers which we are already studied. There are two quantified statements, existential quantifier and universal quantifier. So here, to make a quantified statement to a negation sentence, we will apply this one. While doing negations of quantified statements, we replace the word all by some for every by the exist and vice versa. So we'll change the word all by the word some and some by the word all. Similarly, for every word with there exist and there exist by for every. So one example is given. All natural numbers are integers. In this one, universal quantifier all is used. So to change the universal quantified statements into negation, we'll apply some in the beginning, or you can write other two ways also. So we'll discuss with the first one. Some natural numbers are not integers. This is the easiest way to make a sentence into negation. So not we are applied after auxiliary verb. In the next one, or you can write this one as there exists a natural number which is not an integer. So we change the universal quantified statement into existential quantified statement. Next is not all natural numbers are integers. So we have applied negation word not in the beginning, then we change this statement into negation. Next is examples. Second example is some students of standard 12 are 18-year-old. So here some students of standard 12 are 18 years old is given. So the word we can change with none of the students of standard 12 are 18 years old. That means the word none is used in the beginning of the statement. So it became negative now. Or you can write the word some is replaced by all. So all students of standard 12 are not 18 years old. So we have applied negation here in between. Next example is for all n belongs to n plus 7 greater than 8. Here the given statement is universal quantified statement. So we'll change this with the existential quantifier. So the negation of the given statement is there exists n belongs to n such that n plus 7 less than or equal to 8. So in this kind of statements, mathematical statements, you will change greater than with less than or equal to with not equal to, like that. So here we change this into negation. Next example is there exists n belongs to n such that n plus 4 greater than 9. So existential quantifier we have applied in this one. Now to change the sentence, we will change this with this quantifier with universal quantifier. There are for all. So for all n belongs to n plus 4 which is less than or equal to 9. Next, exercise questions. So there are some questions given to you. You have to solve it. So write negations of the following. There are 5 questions given to you. Next topic is converse, inverse, and contrapositive of a statement. From implication, P implies Q, we can obtain 3 implications called converse, inverse, and contrapositive. So we have to study the statements properly. Formulas. So converse of P implies Q is Q implies P. So converse of P implies Q, you have to write like this. So first you will write the second statement, implies, then the first. Now inverse of P implies Q is negation of P implies negation of Q. The third one is contrapositive of P implies Q is negation Q implies negation P. So you have to by heart all these 3. Now examples. Write the converse, inverse, contrapositive of the following statements. The first one is, if a function is differentiable, then it is continuous. Here there are 2 simple statements is connected with implication, if then word. So first statement P is a function is differentiable, and the second simple statement is a function is continuous. Now we have to write the given statement in symbolic form. That is, symbolic form is P implies Q. Now you have to apply converse, inverse, contrapositive of the given statement. So first one is converse of P implies Q is, we have to write the formula. Then we will apply after if, you have to write the second statement here. That is, a function is continuous. After that implication place you will apply then you have to write the second statement, that is, it is differentiable. So the order is important here. So first after the word if you will write the second statement first, then implies first statement. That is the order here. Next is inverse of P implies Q is negation P implies negation Q. So you have to write after if the negation of the first statement, then negation of the second statement here. So if a function is not differentiable, then it is not continuous. Next is contrapositive of P implies Q is negation Q implies negation P. So after the word if, you will write the negation of the second statement, then you will write the negation of the first. So if a function is not continuous, then it is not differentiable. Next example is, a family becomes literate if the woman in it is literate. So in this example, we already discussed this kind of implication statements and the topic we already discussed in implication topic. So here, a family becomes literate. That is one simple statement. But after if, the woman in the family is literate is given. So we have to give name according to the first happening thing as first and second one as Q. So here, if the woman in the family is literate, then only the family become literate. So first you will give P as the woman in the family is literate. Then you will write Q as a family become literate. Now you have to write the symbolic form of this, that is P implies Q. Now first is converse of the given statement P implies Q is Q implies P. That is, if after the word if, you will write the second statement. If a family becomes literate, then woman in the family is literate. Next is inverse of P implies Q is negation P implies negation Q. So here, after the word if, the woman in the family is not literate. Negation applied here. Then, a family does not become literate, because in this second statement, auxiliary verb is not given directly. So, we have to check the tense. Here it is simple present. So, does is the word here. So, does not become literate. Next is contrapositive of P implies Q is negation Q implies negation P. So, if a family does not become literate, then women in it is not literate. Now, rewrite the following statements without using if then. That means you have to rewrite the given sentence, which is uh, implication statement. If then word will be there in that. So you have to remove these two, then you have to rewrite the sentence. The question is, if price increases, then the wages rise. So it is an implication word is there. So if then is there. So you have to rewrite the sentence without this if and then. Now the first statement here is price increases, and the second statement here is the wages rise. That is, let P is prices increase and Q is the wages rise. Now symbolic form of this is P implies Q. Now you have to rewrite, because without if then you have to write. We already studied this formula in the previous video. So P implies Q is equivalent to negation P or Q. So you will write negation of the first statement first or the second statement. That is, prices do not increase or the wages rise. Now some exercise questions are given to you. Without using if then you have to rewrite these sentences. Thank you.